morning. Welcome back to the course Engineering Metrology, and I am taking statistics in metrology part in this course. So, this lecture will continue the probability distributions. Next, I will move to the proportions. Now, the binomial distribution forms the basis of statistics of proportions, statistics for proportions. Proportion is just a binomial count divided by n. As I discussed about proportions when I discussed the binomial distributions in the previous lecture. Now, for example, we have 200 cases and we find 60 smokers. So, x is equal to 60, but the observed proportion is 0.3. Now, in this case 60 by 200 is 0.3, x is equal to 60. Now, how to use statistics here? I will just discuss this. How to use binomial distribution? For that, statistics for proportions are similar to binomial counts, but differ by a factor of n. So, statistics for proportion can be written as the mu, the value of mean, is equal to n into p. Okay, and this actually differs by, it means it differs by a factor of n, and for the sample, I will put it sample, the standard deviation is equal to n p into 1 minus p. I can even use npq. Q is actually 1 minus p only. So, standard, this is actually variance. Variance is this value and standard deviation is under root of this. So, that becomes np into 1 minus p, the earliest standard deviation. Now, this also differs by a factor of n. This is for binomial actually. Okay. And for proportions, this value mu p is equal to p only, and this is for p is for proportions, this is not for population, proportions, and variance for proportions is equal to n p into 1 minus p by n square, which can be put as p into 1 minus p by n. So, that means standard deviation for proportions is equal to under root of p into 1 minus p by n, where p is the probability of success. Okay. Now, I have a problem here, numerical problem here. A medical factory that amounts, a medical factory is interested in to find the amounts which go into the bottles of eye drops, which are supposed to be normally distributed with mean 36 ounce and standard deviation 0.1 ounce. Once every 30 minutes a bottle is selected from the production line and its contents are noted precisely, the amount of bottle goes below 35.8 ounce or above 36.2 ounce, then the bottle will be declared out of control. So, you see the figures, mean is here, standard deviation is here. Now, they say the bottle will be considered out of control if it is between 30.8 and 36.2. Now, first question is, if the process is in control, that is mean is equal to this and sigma is equal to this, find the probability that bottle will be declared out of control. Now, you know, here the important aspect is the process is in control, the process of filling the bottles is in control. Now, we need to see that the bottles that we have produced, are they in control or out of control. So, to find this, okay, let me first read out the other questions here. In this situation of problem number 8, when the problem is out of control, find the probability that the number of bottles found out of control in a 8-hour day, that is 16 inspections, will be 0. Okay, in an 8-hour day where 16 inspections happen, that will be 0. Okay, in the situation of the problem A, when it is out of control, find the probability that the number of bottles found out of control in an 8-hour day will be exactly equal to 1. Okay, if the process shifts so that mu changes and standard deviation changes, and find the probability that the bottle will be declared out of control. Find the probability that the bottle is or will be declared out of control. Okay. Now, first part is just a normal distribution as we did. Mu is this, sigma is this, we have a lower bound, we have a upper bound. Okay. So, let me try to put these values. So, I have the lower bound as first of all I have mean as 36 ounce and standard deviation as 0.1 ounce. I have values of x, the lower bound and upper bound as 35.8 ounce and 36.2 ounce. Okay. So, I need to find the probability that it is out of control. That means whether x is out of control, whether x is less than 35.8 or probability whether x is greater than 36.2. Okay. So, this probability plus this probability, this is part A. When we try to compute this thing, we donate normal distribution as random variable x is normal with mu and sigma, which means that this is a normal distribution with 36 and 0.1. Now, for this I need to calculate the value of z. If I see the value of z for this is equal to z less than, I will just put the value of z for 35.8 x minus mu, that is 35.8 minus mu, that is 36 by sigma 0.1, okay, plus probability of z, value of normal deviate greater than 36.2 minus 36 by 0.1. This is equal to probability of z, this is actually 0. Less than 0.2 by 0.1 plus probability of z greater than again 0.2 by 0.1. This is equal to probability z less than 2 plus less than actually minus 2 here plus probability z greater than 2. So, this value for minus 2 and 2 we need to see, and if I go to the table and try to find this value would be 0.0228 plus this value would be 1 minus 0.9772, which means 0.0228 plus 0.0228, this is equal to 0.0456. Okay. So, you can see the value at 2 here. So, z is equal to 0.4772. For the other table, it would be 0.5 minus this value, which is equal to 0.228. Okay, this is for question number 3, part A. Now part B. In the situation of A, when the process is out of control, now we have got the probability here, okay, which is equal to 0.045, maybe 4%, 4.5% of chances are there. Now, if the probability that the number of bottles found out of control in an 8-hour day, 16 inspections would be 0. Now, what we have here is, in B, we have 16 inspections. So, what is this value? This is value of n in case of binomial distribution, and the probability of success, actually the probability of out of control, is equal to 0.0456. So, now you see that from normal distribution, first we find the probability. Now, this probability would be used as proportions, or maybe as a probability of success in binomial distribution. Then the question is progressing further. Now, this p is equal to this. Now, what is the question asking? It is asking the probability of out of control, that the probability that it is out of control and bottles found out of control will be 0. Bottles found out of control will be 0. So, let us see here carefully that out of control, this P is success, and they need when none of the bottle is out of control, that is P for x is equal to 0. For x is equal to 0, the relation that I have, it would be NC 0, then probability of out of control NC 0, P power 0 and 1 minus P power 16, which is equal to N, that is 16 C 0, 0.0456 power 0 and 1 minus 0.0456 power 16. Okay. Now, this value, if I calculate, this value comes down to 0.4739, that is, we can say 47.4% of chances that none of the bottles are out of control from a sample of 16 bottles. Okay. Now, let us try to do part C. Now, the part C is similar to part B, but the only difference is that he says that bottles out of control will be exactly 1. Now, we need to find the value of x exactly equal to 1. Part C, when probability of x exactly equal to 1, this is again we can put it this is equal to NC1 P1 1 minus P power n minus 1. Okay. So, this is equal to 16 C1 0.0456 power 1 and to 1 minus 0.0456 power 16 minus 1, that is 15. Okay. If I calculate this, this value will come 0.3623, that means 36.2% of chances that exactly one bottle will be out of control in a sample of out of control in a sample of 16 bottles, or inferred from a sample of 16 bottles. So 16 inspections, inspections. Here also it will be inspections. I'm so sorry for this. 16 inspections. So next, if the process shifts so that mu is changed, sigma is changed, now find the probability that bottle will be declared out of control. Now mu and sigma is changed. Now we have a new normal distribution, that is normal distribution is n with a changed value of mu, that is 37, and changed value of mu, that is equal to 0.4. We need to check the probability that whether it is out of control or not. I think we just need to do the calculation similar to question number A. We just only the value of mu and sigma are changed, and we can find the probability in a similar fashion. Now for this we need to find whether probability for x is less than 35.8 plus probability of x is greater than 36.2. Okay, in this case you can see that both the lower and upper bound 35.8 and 36.2 are less than the mean value 37. So upper bound is also lower. So we will be lying somewhere here in the new probability distribution. This is 37, so it is 35 and 36, 35.8 and 36.2. Okay. Now we are on this side, probability less than this, greater than this, but the essential part would be this will be some minus value, this will be some minus value, the value of z, this will be negative values. So we can say it, this is equal to probability for z less than 35.8 minus 37 by 0.4 plus probability of z greater than 36.2 minus 37 by 0.4. If I calculate this is the probability of z less than minus 3 plus probability of z greater than minus 2. So this value is minus 3, this is minus 2. So if I locate this probability or trace these probabilities on the probability distribution table of normal distribution, I will find that this probability is 0.0013 and this probability is 1 minus 0.0028. Okay, this total probability is 0.9785. So when the mean is shifted, when the upper bound is even lesser than mean, we find that the probability of the process that would be out of control is very large. This is 97.85%. In the case A, the probability was 4.5%. So why is this big shift? If I see the previous, this is actually part D. Okay, if I draw the plot for part A, it was like this: 36, then 35.8 and 36.2. Now we see we are interested in the area that is before 35.8 and after 36.2. This area was too small here. This area in the part D is very big. So you can see when the shift of the process is there, so the probabilities can change dramatically. So next I have another question. The statistic of a well defined varying voltage signal are given by x dash is equal to this, and variance is given. If a signal measurement of the voltage signal is made, determine the probability that the measured value indicated will be between this and this. okay, this volt and this volt, 10 volt and 11.5 volt. So now I'll just draw the curve here. X dash is 8.5 and this is 10 and 11. I need this probability. So, I will leave this question for you and we will have the questions in the quiz based upon this question. Just be mindful that this is sigma square, this is variance, we need to take under root to find the standard deviation. So, this is left for you. So, we will meet in the next lecture, we will discuss the statistical parts in metrology further. Thank you.